In Module 6, Lesson 1, we're going to learn to write and solve one-step equations. This is where we're really going to start getting into some of that big boy math and showing our work algebraically. From here, we got students will write and solve one-step equations with rational numbers for your content objective. Suggested pacing guide says this one's going to take us a while. We love long lessons, don't we? So let's go ahead and get started in what we're working on so we can get finished with what we're working on. The largest salt lake in Australia is Lake Erie, I don't know, located in the South Australian outback. The lake is normally dry and rarely fills to capacity. A salt lake is a body of water that has a high concentration of salts, significantly greater than most lakes. When full, the surface of Lake Erie, the surface elevation of Lake Erie is -9 meters. The elevation is 6 meters greater than the deepest part of the lake. So it sounds like even when it's full, its elevation is below sea level. The equation x plus 6 equals -9 can be used to find the elevation x of the deepest part of the lake. And you know how to solve equations with whole numbers such as x plus 6 equals 9. And how can you use this knowledge to help you determine how to solve an equation with rational numbers such as x plus 6 equals -9? These are some of the things we're going to be learning and talking about in this lesson. Now, our inquiry question says, how can algebra tiles help you to solve one-step equations with integers? Well, let's get into that and we'll find out. Now, if you remember, the value of a zero pair is 0. And you can add and subtract zero pairs from either side of an equation without changing its overall value. So here you can see a plus 1 minus 1, that equals 0. A plus x minus x, that equals 0 as well. Now the textbook wants us to answer what equation is going to be modeled on the map, and that is going to be x plus 4 is equal to a -5. Not hard to figure out at all. Now we need to come up with a plan so that we can isolate the x tile. Remember, the final goal of an equation is to isolate the variable. And if we do something on one side of the equation, we're going to have to do it on the other side. And my plan is very simple. I'm going to take and move everything from here, move my pieces from here to the opposite side by doing an inverse operation. So what I'm going to start off with is I'm going to add a -1 and a -1. Remember, if you do it on one side, you have to do it on the other. And these two here, they just took and zeroed out. So now they're gone. So let's do another set of -1s. Another -1 and another -1 here. If you do it on one side, you have to do it on the other. And these two -1s, they just zeroed out as well. Do it again, a -1 and a -1. So these two ones just zeroed out. And finally, a -1 and a -1. So these two ones zeroed out. And what are we left with in the end? We have x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So our final answer to that equation is going to be x is equal to 9. Now they're going to give us an equation. The equation that they give us is x minus 3 equals 2. So we have to build that equation using our algebra tiles. And from there, we're going to have to take and isolate the variable to find a solution. So let's start off with our equation. We have x minus 1, 2, 3, and it's going to equal to a -2, 1, 2. So that's the basic problem. Now we need to solve our problem. To solve it, we're going to take and do inverse operations. So I'm going to add 1 to both sides here. I'm going to add 1 to both sides here. And I'm going to add 1 to both sides here. Now you notice that these ones, they're all going to zero each other out. So that's 1, 2, 3 that we remove from the left-hand side. On this pair, I'm going to have 2 that are going to zero each other out. So what's the final equation going to be? X is equal to 1. And that's going to be what the value of x is. X's value is just 1. But what if you had something like this modeled on your map? Well, we have 2x is equal to a negative 8. Well, that one's very easy to work as well. We're going to break it into two different groups. We have one group. Let's do equals on each side. We have one group on the top, and we have one group on the bottom. So because of this, we can look at it and say that each group of x is equal to how many? Negative 4. So the solution to that equation is x is equal to negative 4. Stuff really is pretty simple when you look at it with algebra tiles. Now the next equation they want us to build, and they say 3x is equal to negative 9. So we're going to start off with 1, 2, 3 x's, and then we're going to drop in a whole bunch of negative 1s to equal negative 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. From there, we're going to regroup it. I'm going to put an x on the top, an x on the bottom, and an x in the middle. And then we're going to start breaking down our 1s. Our negative 1, I have 1 here, 1 in the middle, 1 in the bottom, 1 in the top, 1 in the middle, 1 in the bottom, and 1 in the middle, 1 in the top, and 1 in the bottom. And what's the value of each x going to be? Each x is going to represent negative 1. It really is that easy to do these using algebra tiles. But as much fun as algebra tiles are to play with, they're not really an effective way to solve equations when we have a whole bunch of them to do. So instead of using algebra tiles, we're going to use this little thing called the addition property of an equality. You're going to need to highlight that. That's one of your vocab words, and the definition of it says that the addition property of an equality states that the two sides of an equation remain equal when we add the same number to each side. Looking at that in symbols, we could say if A is equal to B, then A plus C is equal to B plus C. They added C to both sides, and that's okay. It kept the equation to be the same exact thing. We also have the subtraction property of an equality. That's going to be another vocab term, and when we look at it, it says the subtraction property of equality states that the two sides of an equation remain equal when you subtract the same number from each side. And looking at it in symbols, it looks like that. The only difference between the addition property and the subtraction property is the plus sign or the minus sign. That's it. If you do the same exact thing on each side of an equation, the equation stays true. We also have a couple of other properties to look at. You've got the multiplication property of an equality, another vocab term, which says the same exact thing, only involving multiplication. And you have the subdivision property of an equality, also a vocab term. And guess what? It says the same exact thing again, only now it involves division. So your addition, subtraction, multiplication, and division properties all have the same exact thing going on with them, except it applies to each of the individual operations. An equation is defined as a sentence stating that two quantities are equal. We're getting a lot of vocab words out of this lesson. And the value that makes the equation true, well, that is what we call the solution. So you picked up two more vocabulary terms here. We have the equation x plus 2 is equal to 6, and another equation that says x is equal to 4, and these two equations are equivalent equations, another vocab term, because they have the same solution. So for x, so if you took this one and solved it down, you would actually get that one. Because both will have the same value for x, they're known as equivalent equations. Example 1 has to solve in the equation negative 5 is equal to the sum of b and 8. Where the final goal of any equation, that's going to be to isolate your variable. Your variable is going to be b, his friend is 8, and 8 is doing what? 8 is adding itself to b. So what's the inverse operation of plus 8? Well, that's going to be minus 8, and that's going to be using the subtraction property of an equality. Now, if it was me doing this, I would draw a line through these two 8s on the left because they zero each other out. The 8 minus 8 is equal to 0. We used to call it cancel each other out back in the day, but high school teachers get kind of testy about that because they say cancel is not a proper mathematical word, so they don't like it. From there, what's left on the right? Just b. And on the left hand side, I have signs are the same. Find the sum, which is going to be 13 with a sign in front of your larger number going in front of your answer. That means that B is going to be equal to a negative 13 for your final answer. The same exact thing they put right there. And now it's going to be your turn. Pause the video and solve this equation using big kid math, and I'll go ahead and tell you, you're going to use the subtraction property of inequality for this one. To solve this problem, I'm going to take and start off by asking the questions. What's the final goal of an equation? To isolate the variable. My variable is x and its friend is 4. He's adding 4, so I'm going to take and, subtract 4 from both sides. The 4's on the left, zero each other out, leaving x is equal to, signs are the same, find the sum, sign in front of a larger number, goes in front of the answer. So, jump back over here, x is going to equal to a negative 7, check it, and it works. That's all there is to doing these. This is where we're going to stop part 1 of this video. Come back in just a little bit and watch part 2 where we're going to solve a one-step subtraction problem.